Okay, so this is the key to worksheet 10.6 part A, and in number 1 you want to find the domain and range of each of the given relations, and you want to use proper notation to write the domain and range given these relations, and then also determine whether each relation is a function, and you can write yes or no in the in this part here. Okay, so notice that remember a relation is a set of ordered pairs. So notice these are sets of ordered pairs. Now these are a finite set of ordered pairs. Finite meaning you can actually count how many ordered pairs there are. So in this case there's 1, 2, 3, 4. Over here there's 1, 2, 3, 4, 5, and so on. All right, so that's a finite set. Whenever there's a finite set, you have to list a domain and range in a certain way. You can't list it as an interval. You can't use interval notation. You cannot use inequality notation. So you have to list it as a set and actually listing the elements of that set. So for example, remember the domain is a set of x coordinates. So since I have a finite set of x coordinates, I'm going to use set notations. I'm going to use the braces here. Not parentheses, use braces. That's proper notation. And so my x-coordinate here is 1, my x-coordinate here is -4, my x-coordinate here is -2, and my x-coordinate here is 2. All right, so that's the domain. So the domain of this relation has 4 elements in it. I did not put them in numerical order. It does not matter, just as long as you list the elements of this relation in terms of finding the domain. The range is the set of y-coordinates. So these are your y-coordinates. And so you just go to your set. Again, that's a finite set, so we're going to list it in proper notation. So we're going to say braces, not parentheses, braces, -2, 6, -3, and -1. Now also notice we separate these using commas. Okay, now let's talk about a function. A function is a relation. So remember, relation is a set of ordered pairs, but a function is a special kind of relation. For each x-coordinate, there is exactly one y-coordinate attached to it. So sometimes it's best if you use the idea of a mapping to help you with this. So here's my domain, here's my range, and remember the domain is for each x, there's got to be exactly one y-coordinate associated with it. So when x is 1, my y-coordinate associated with it is -2. So far, for this x-coordinate, there's just one y-coordinate. So far, it looks like we have a function, but you got to check all of these. So if x is -4, my y-coordinate is 6. So far, we're good. If x is -2, my y-coordinate is -3. If x is a +2, my y-coordinate is a -1. So notice that for each of these x-coordinates, there was only one y-coordinate associated with it. You see there's only one arrow coming out from each of those x-coordinates. So therefore this is a function. Okay, number 2, letter B. So the domain, again, is a set of x-coordinates. So you have -2, use proper notation, -5, 4, and 2. All right, so that's the elements of my domain. The elements of the range, you have the set of y-coordinates. So 3, notice that all of these y-coordinates are 3s. You only list it once. List it once. Don't list it more than once. You list it once. So that's the only element in my range is 3. All right, now let's determine that's a function. So again, I'm going to use a mapping like this. So here's my domain. Here's my range. And so when x is -2, my y-coordinate is 3. When x is -5, my y-coordinate is 3. Now don't list it again. You've only list the elements once. All right, so I have that. When x is 4, my y-coordinate is 3. And when x is 2, my y-coordinate is 3. Now this one confuses students because and probably because they don't understand the definition of function. Notice that a function for each x, there's only one y associated with it. So when x is -2, is there just one y value? Yes, there is. It's 3. When x is -5, is there just one y value? Yes, there is. It's 3. If x is when x is 4, is there just one y value? Yes, yes there is. It's just 3 and so on. So this is a function. So it is okay for the same y value to have multiple x values. But the definition of function says for each x, there's one y, and there is in this case. For this x, there's one y, for this x, there's one y, and so on. It just happens to be the same y value. That's fine. It's still a function. Over here, if you notice, all of my x coordinates are the same. You only list it once. List it once. And the range is -1, 4, 0, 3, and -5. So that's my range. And then let's determine if that's a function. So I'm going to use that same idea. So here's my my domain, and then my range. So when x is 2, again, you only list the elements once if they occur more than once. If x is 2, my y value is -1. My y value is also 4. My y value is also 0. My y value is also 3. And my y value, I'm going to just do this here, is also -5. So notice that when x is 2, you have more than one y value associated with it. So remember, when x is 2, there's got to be just one y value. When x is 2 here, the y value is -5, the y value is -1, and so on. So this is not a function. That's not a function. Over here, the domain, so again, it's just a set of x coordinates, so -4, comma, 3, comma, -2, comma, 2, comma, -5. And then your range would be 1, 4, 4 again, I already have it listed, 3, and 5. All right, so let's see, that's a function. So it helps if you do this mapping, because you can visually see how many arrows are coming from the x coordinate. So when x is -4, my y value is 1. When x is 3, my y value is 4. When x is -2, my y value is 4. We're okay so far. It's okay for this to occur right here. For each x, there's just one y value. And when x is -5, my y value is 5. So that is a function. Over here, my domain is 4, -3. I already have -3 again, 2, and -5. So for each x coordinate, there's one. I'm sorry, the domain is a set of x coordinates, and the function is for each x coordinate is only one y value. The range is 1, 4, -4, 3, and 5. All right, so that's your range, a set of y coordinates. And so let's see, that's a function. So we're going to look at this mapping. So when x is 4, my y value is 1. When x is -3, my y value is 4. So far we're okay. When x is -3, I already have it listed. My y value is a -4. Now, at that point, I can really stop. I don't have to go any further because it's not a function. And all you want to know is this a function? And you found right away that this can't be a function because when x is -3, I have two different y values. So that's not a function. All right, now let's look at the next problem. So number 2. Now so when you look at number 1, these relations were a finite set. So you can actually count how many elements are in that set. Here, these relations right here, see all these are set of ordered pairs on the graph. This is an infinite set of ordered pairs. So you can't list them like we did the domain and range here. Since that's an infinite set. That's an infinite set of ordered pairs, that's an infinite set of ordered pairs, and that's an infinite set of ordered pairs. So we're going to have to use, in this case, interval notation. Okay, so let's talk about that. So when doing this, it's a good idea to use some kind of ruler or straight edge to help you to see what the domain and range is. Okay, so let's talk about the domain and range. All right, now notice that this graph, this relation, the arrow keeps on going like this. All right, so you've got to visually see it going on all the way like this. And so the question becomes, I remember you're finding domain, so the set of x coordinates. So you're going along the x-axis. See it like this? So when x is negative 3, for example, I have a y value. When x is negative 2.8, I have a y value, and so on. So you're trying to find, if you look at all these ordered pairs, what are the possible x values you can have for these ordered pairs? So it's just not negative 3. It is just not negative 2. It is just not negative 1. It's just not negative 1/2. You could have, let's say, a positive 10, because way down here is a point of the graph. There's a point somewhere where x is 10. There's a point somewhere, if this is 100 right here, x equal 100. There's a point way down there on the graph where the x coordinate is 100, and so on. Same thing on this side. If I were to extend this, you got to visually see this. If I were to extend it to, let's say, negative 100, there's a point way down here where the x-coordinate is negative 100. Negative 1,000, there's a point way down there, because you got to visualize this doing this. This graph does not stop. It keeps going down like this, so you got to visually see that when x is negative 1,000, or negative 100,000, or negative 1,000,000, there's a point way down there where the x-coordinate is that value. So we discussed that since there's no bound here, I can keep on doing this, that we're going from negative infinity. So for my domain, I'm going from negative infinity all the way to positive infinity. And remember, when writing the interval notation, you always go from smallest to largest. So you go from left to right. So I'm going from negative infinity all the way to positive infinity. So that's your domain, negative infinity to positive infinity. And make sure that your infinity symbol looks like infinity symbol. All right, now let's talk about the range. So the range, you're going along the y-axis. Now notice that these arrows are going down. So when you look at this, so if I look at this y value right here, see that negative 1? There are 2 points on the graph that are associated with negative y equal negative 1. So negative 1 would be in my range. Same thing for negative 2. There's a point here that's associated with negative 2. So that would be in the range. But remember, this is an infinite set of ordered pairs, so you can't list them like say, negative 2, negative 1, and so on. So you have to use interval notation. But you got to remember that negative 2 is not the lowest, is not the smallest y value. Negative 3 is not the smallest y value. Negative 4 is not the smallest y value. Negative 10 is not the smallest y value, because the graph keeps going down like this. So basically, you got to think, well, is negative 1,000 the smallest y value? No, because you have these arrows that keep on going down. So you're going from negative infinity all the way to, and then you got to determine what's the largest y value. Well, there is a largest y value here because the graph stops here. So you got to just figure out, well, what is that y value? Well, that y value here is 4. And since this point is a solution, remember, and when you're looking at graphs, the graphs represent solutions to whatever that equation is. So you're going to use a bracket. So I'm going from negative infinity, parentheses, because remember, always use parentheses with infinity and negative infinity, comma, all the way to 4 with a bracket. All right, now let's talk about whether this is a function or not. Okay, so remember, we talked about the vertical line test. So if you look at this, when x is negative 3, I get this y value right here, where the y value is a positive 3. So when x is negative 3, there's only one y value. When x is negative 2, there's only one y value. It's positive 4. When x is 1, there's only one y value, whatever this y value is. I'm not going to estimate it, but whatever that is. So when talking about a function, we can use the vertical line test. Remember, the vertical line test says that no matter where you draw a vertical line, if it intersects the graph once each time, then that relation represents a function. So notice that this does pass the vertical line test. So this is a function. Okay, so over here, do the same idea with the ruler. So let's talk about the domain. So this time the arrows are pointing up, but with regards to the domain, that doesn't matter whether it points up or points down, because notice And you got to visually see this, that it doesn't go straight up like this. All right, so because then it would no longer be a function. It does this. All right, so when x is, see, this is -5 right here. So when x is -5, I get a point on the graph. When x is -10, I get a point on the graph. It's way up here. When x is -100, I get a point on the graph. It's way up here. So in this case, you got to think, well, I'm going from -infinity all the way to, and then the same thing here. When x is 10, are you going to get a point on the graph? Is there a point on the graph where the x-coordinate is 10? Yes, because you notice it keeps doing this, way up there. When x is -1,000, I'm sorry, +1,000, I have a point on the graph where the x-coordinate is +1,000. So I'm going from -infinity all the way to +infinity. Remember, we always go from smallest to largest. Now let's go about the domain. Domain, remember, you go along the y-axis. So the question is, for example, is y equal 1, is that the smallest y value on the graph? So this point the y value is 1, this point the y value is 1, and the answer is no. Because look at this, there's a point below it. So this y value is smaller than the 1, so this is 0. So, but that's not the smallest. The smallest, when you go from remember, when indicating an interval, you go from smallest to largest. So go from bottom up along the y-axis. So there is a smallest y value, and that's this right here, -2. And then notice the arrows keep going up, so it never stops. So you're going from the y value -2, -2, all the way to +infinity. But remember, you got to use a bracket for -2, parentheses for infinity. And notice it does pass the vertical line test, which means that for this x value, there's only one y value. For this x value, there's only one y value. For this x value -4, there's only one y value, and so on. So this is a function. All right, the same idea here will be used just like it did here. So notice the range. Remember, range go along the x-axis. So when x is -1,000, I get a point on the graph that represents an x value of -1,000. So you're going from -infinity all the way to +infinity. That's the domain. Go from smallest to largest. It's got to be -infinity, then you list infinity. The range, okay, remember the arrows are pointing down, so the range, you're going from -infinity, and there is a largest y value. That's this right here, y value of 3. So I'm going from -infinity to 3 with a bracket, and this is a function. It passes the vertical line test. All right, so that's going to take care of the key to this worksheet.